This week's episode of Cool Stuff You Can Do with Science. I'm your host, Erwin Meyer Flask. On this week's show, I have three special guests with me to discuss nuclear fusion. Our first guest is Dr. Bob Scoboom from the University of Stanford. Our second guest is Dr. Wingett, who has written multiple books about nuclear fusion. Our final guest is Dr. Hawkins, who works here in Louisville. Gentlemen, thank you for joining me this evening. Fusion, the clip you just saw is what comes to most people's mind. However, this technology has applications outside of the military. A few years ago, the National Academy of Engineers issued its Grand Challenges, a collection of issues they believe modern engineering can improve. Nuclear fusion was one of those challenges. Dr. Scoboom, what specifically is this challenge trying to address?
First off, let me explain what nuclear fusion actually is. Nuclear fusion is a special reaction that occurs when two atoms' nuclei collide with each other at extremely high temperatures and pressures. The two nuclei, with all their protons and neutrons, are additively combined, but some mass is lost. According to Einstein's famous equation E equals mc squared, a massive amount of energy is released, the magnitude of which could power the explosion we just showed you. This process is actually what powers the sun. So far, engineers have only demonstrated this reaction on an extremely small scale. If we could recreate and control this on a larger scale, we could produce so much energy.
Dr. Wingett, what factors contributed to needing nuclear fusion in the first place?
For most of the world's population, fossil fuels are the main source of energy. As we know, fossil fuels are pollutants and directly contribute to climate change. Furthermore, they are non-renewable and will eventually run out. Nuclear fusion represents a clean, abundant, and renewable alternative to fossil fuels.
What are some potential solutions engineers could come up with to solve this problem?
The biggest problem with nuclear fusion is scaling it up. We already can create these reactions on a smaller scale. However, the extreme heat and radioactive pressure in nuclear fusion causes an endless chain reaction, making it challenging to viably sustain fusion. To counter this, engineers and scientists need to find an economically viable way for reactors to withstand these extreme conditions.
Well, that's all the time we have this week on Cool Stuff You Can Do with Science. Join us next week as we discuss Shark Week.